Good morning, fellow participants. We are on the 7th module of our presentation on the topic development of resilient transport infrastructure in Africa. Module 7 is titled Emerging Issues in Transportation Infrastructure and Services. Like I always start my presentation, I give a background of the summary. And in this course, the summary will start with introduction, definition, historical, STI architecture. STI is intelligent transport system. Why use STI? STI importance, categorization of intelligent transport system application, services provided by intelligent transport system, new vehicle types stroke road innovations, ITS perspective for resilient infrastructure, ITIs and other modes of transport, the R5G, what will the R5G look like? Then conclusion. Introduction. With the increase in the vehicle fleet, rampant urbanization, population growth, and changes in population densities, road traffic congestion problems are constantly increasing. These congestion problems reduce the efficiency of transport infrastructure and increase journey times. While on the other hand, pollution, which accelerates climate change with greenhouse gases and fuel consumption. On the other hand, the synergy of a new information technologies in the field of simulation, real-time control and telecommunication networks offer services that can facilitate the optimization of the overall management of different elements, whose individual management is usually opposed. These different elements relate to vehicles, transported loads and transport routes with the aim of improving safety and reducing vehicle use, transport times, and fuel costs. The combination of these two situations created the Intelligent Transport System, ITS. The program Intelligent Transport Systems, STI, in English, Intelligent Transportation Systems, is a global initiative to integrate ICT into transport infrastructure as well as vehicles. The STI is an interactive system for collecting, processing, and disseminating information applied to transport based on the integration of information and communication technologies to infrastructure and vehicles so as to improve management and transport operations, operation of transport network and user services. New technologies applied to transport networks are to improve 1, management, 2, operations, and 3, user services. At the base, we find computers, electronics, and telecommunications. The historical angle of intelligent transport system, these were born from the recognition by the public authorities of the limits of transport systems with the increase in the phenomena of congestion and road accidents. The intelligent transport systems appeared in the late 1960s and early 1970s, notably with the Comprehensive Automobile Traffic Control Systems, CACs, which was first in Japan, or ERGS, which is Electronic Route Guidance Systems, commonly in Germany and the United States. Thus, From the deployment of the first traffic lights in the United States in the year 1914, or in Europe, in France in 1923, to the installation of the first parking meter, which was designed and installed in 1935. The logic of the first measures taken to manage transport boils down to a superimposition of innovations focused on road infrastructure. This logic of innovation will gradually shift towards the vehicle with, in particular, an emphasis on safety, a priority of the public authorities with the increase in the vehicle fleet and the implementation of new standards. Here is the historical overview of all of this technology from the year 1914, 1980, 1990, and the year 2000. In 1914, there was the recognition of the limitation of transport system, opportunistic and non-system innovation on the part of the actors. The innovation here focused on vehicles and highway guidance systems. It was a public program. In 1980, there was a deployment of Intelligent Vehicle Highway System, IVHS, which was the connection of the vehicle to the infrastructure. And then there was a group innovation, Schuptemarian's process of innovations cluster. Here, investment opportunities for economic players was also with the connection of public program to private research programs. The term Intelligent Vehicle Highway System is replaced by that of the Intelligent Transport System, STI or ITS, to recognize the multimodal nature of the transport activity and for the emphasis of vehicle guide technology. This was developed in 1990. The loop back of the system, that is vehicle to infrastructure to management system, then to the driver. So it was an interwoven way of working, technological working, and the program of private companies are growing where budgetary restrictions for the states. While in 2000, generalization of the intelligent transport system and new perspective management of a complex system in which it connected vehicles and autonomous vehicles evolved. New players in intelligent transport system, for example, Google, Apple in competition with traditional automotive players. Why ITS architecture is important? In the past, road traffic control systems were often installed to provide only one or two independently operating services as separate subsystems. On the other hand, complex management, regulations, and data collection services are implemented simultaneously in the context of ITS. The system architecture provides the required logical framework based on user requirements for their planning, definition, and integration of intelligent transport systems. The intelligent transport system architecture defines the following in this order: functions, for example, collecting traffic information or requesting a route that are required for its operation. The physical entities or subsystems in which these functions reside, again, for example, on the road or in the vehicle. Information flows and data flows that link these functions and physical subsystems into an integrated system. The intelligent transport system architecture analysis provides additional assistance in planning and implementing the ITS deployments. These include a deployment schedule, an organizational perspective, a cost-benefit analysis studies, and also a risk analysis to make it work. The reference framework, which describes the relationships established between the physical elements of transport network, the needs for information and communication systems, the mode of data sharing, as well as the standards listed for the delivery of a transport service. An intelligent transport system architecture generally defines the functionality of the constituent elements of intelligent transport systems that are grouped together and the flow of information between these systems. An ITS architecture consists of a physical architecture and a logical architecture. An ITS architecture generally defines the functionality of the constituent elements of intelligent transport systems. Why use this system? The intelligent transport system make it possible to offer services that meet the needs of different user segments. It disseminates more information more often and in a better quality. It implements advanced operating assistance systems, that is adherence to the schedule, using the global positioning system, GPS, etc. It goes from planned static to dynamic, which is live. It makes information available on a multitude of media. Still on why use this system? Ultimately, the intelligent transport system make it possible to optimize the use of infrastructure transport, improve on security. It continues to improve the quality of the services offered. It reduces inequalities, and then it gives the environment the needed protection. Intelligent transport system represent a combination of advanced information and communication technologies. They are used in road transport and traffic management systems to enhance the safety, efficiency, and sustainability of road transport networks. That is to say, it also reduces congestion and to improve the driving experience. The importance of this technology is that the possibility with ITS are endless. One, activities usually requiring human intervention can be automated. The performance of a road network can be monitored and adjusted in real time. Data that was previously collected through expensive infrastructure is now being provided by new, more prolific sources. Analysis from historical data are now performed by intelligence systems through real-time data. Road users' choices, previously dictated only by road signs, can now be influenced by a wide variety of delivery channels, such as mobile devices or in-vehicle systems. And today, intelligent transport system specialists provide expertise in planning, design, implementation, and operation focused on optimizing system performance. These are all importance of the intelligent transport system. Information for users, traffic management, public transport management, electronic payment, commercial vehicle operations, emergency management, advanced vehicle safety systems, information management, management of maintenance and construction work. These are all categorization of its application. Still on categorization of its application, information for travelers. Here, with the use of this system, information on preparation for the trip, information during the trip for the driver, information during the trip on public transport, traffic information, location, etc., are all captured with the use of this transport system. Traffic management. With this system, we can control traffic, we can manage accidents, we can also manage the flow of vehicles, infrastructure maintenance management, that is to say, we can capture where on the roads are bad and will need a turnaround maintenance. We also have the infrastructure planning, etc. With the use of this application, again, public transport. Here, management of public transport, management of on-demand transport, management of shared transport, management of timetables and locations, etc., are all achieved with the use of this application. That is the intelligent transport system. We can also use the intelligent transport system for emergency management, where emergency notification and personal safety of travelers, management of emergency vehicles, management of the transport of hazardous materials, and notification of incidents, etc., can be captured. We can use the intelligent transport system to do electronic payment. Here, electronic financial transactions at toll gates can be achieved. With this system, again, we are sure of safety. Public travel safety, improved safety for users, and then we can also have smart junctions where it is manned or controlled with the use of traffic lights. Vehicle, the improvement of visual coverage, automated operation of the vehicle, collision avoidance, lateral and longitudinal, safety, vehicle maintenance, etc., are all some of the benefits of this intelligent transport system. Commercial vehicles pre-clearance, commercial vehicle administrative procedures, automatic road safety inspections, safety monitoring on board commercial vehicles, fleet management, automated diagnostic systems, etc., are all benefits tied to the intelligent transport system based on categorization. Services provided by these systems. For example, travelers' information. With this system, information before the journey, drivers' information during the trip, information of the public transport user during the journey, individual information services, navigation and guidance can all be captured with the aid of this system. When we look at what can be achieved using traffic management, here, with this system, you can do transport planning, traffic management, incident management, surveillance and repression of infringements, management of infrastructure maintenance, improved vision. With the systems, again, vehicles here can improve vision, automation of driving, anti-frontal collision, anti-lateral collision, passive safety devices, deployment of safety devices before crash. The system also enhances good transport vehicles, where we have pre-control of commercial vehicles, administrative processes relating to the transport of goods, automatic safety inspection, and also load management. With this same system again, you can use it to plan public transport by management of public transport, transport on demand, management of shared means of transport. Then we go to emergency room, where this same intelligent transport system application can alert on safety of the persons, management of intervention vehicles, hazardous materials and incident management. You can use the system again in electronic payments, where electronic financial transactions can be carried out. Security, with the ITS, safety of public transport, security of usage, users are vulnerable, intelligent interface, and correspondence. How can this system work? They are worked with new types of vehicles where systems considered dynamic display, playback of pre-recorded voice messages, telemetry, video surveillance, internet access for travelers on buses and trains, etc., automated and autonomous vehicles. Nowadays, ICTs are completely and definitely integrated into the manufacture of vehicles. Today, some facilities are still optional, but everything suggests that the vehicles of tomorrow will all be equipped with these different gadgets. Our childhood dream of watching the James Bond films, driving hyper-sophisticated vehicles, will then become reality, where vehicles blocked to the face can have automatic adjustment of the driver's seat according to the main user. In the context of climate change, with the severe flooding experienced in recent times, amphibious vehicles and even amphibious buses could fire die pin. What about a bus system regularly connecting Kinshasa and Brazzaville, or crossing the Gambia River or the Senegal River at the level of the city of Rosso? Here, pictorial illustration or explanation of the aforementioned advantage of some of these technologies. Here is a bus that has maneuvered itself and is working like a ship or a boat on water. With new information technologies, digitization, more efficient communication systems, we can expect more innovations in the vehicles of the future. The example is given with the automated vehicles in circulation almost everywhere nowadays, and the autonomous vehicles that are starting to make their way. Cars equipped with advanced driving aids are increasingly emerging as an integral part of technological innovations in driving. They are supposed to improve interactions between drivers, but also between drivers and road environment. They are also capable of intervening directly on the vehicles in the event of a dangerous situation, emergency braking system, ABS, anti-locking system for the wheels, automatic speed regulations. These are all benefits of the intelligent transport system gadgets or categories. While driving automation, making it possible to delegate all of or part of the driving task to an automated system is now becoming a reality, popularized by Google autonomous vehicle experiment that was developed in 2010. The term autonomy comes from the Greek roots, auto, self, and nomos, the rules. Thus, an autonomous vehicle must be able to react by itself according to defined rules. In order to carry out the missions which will be given to it, such a vehicle must perceive the environment and understand it. It must also decide on a maneuver and plan its realization. The so-called autonomous car is equipped with an automatic piloting system which allows it to circulate without human intervention in real traffic conditions. For this, it is equipped with different sensor technologies. That is to say, the scanning laser, the radar in which it operates on, and the camera. The signals from the sensors are then translated using algorithms in the form of information understandable by machines and essential for driving. These are applicable to road markings, signs, buildings, vehicles, pedestrians, etc. As such, different levels of automation and autonomy are offered, depending on the intrusion of this system into driving. This will make it possible to tackle many societal issues, such as road safety, traffic flow, energy reduction, and mobility for all. This last point is essential for our aging society and people with disabilities. Indeed, this possibility of mobility is rewarding and allows the people concerned to regain a degree of autonomy. Still on the new types of vehicle, it was from 2010 that the subject really became media coverage. When Google announced that it was working on this technology, the Californian giant began by modifying production vehicles of the Lexus and Toyota brands before presenting it in 2014. A Google car entirely designed by its engineers. The following year, Google announced that its cars had driven 2.7 million kilometers. These are all referenced and can be captured with the under quoted link when you link to YouTube. With this innovation of intelligent transport systems as applicable to roads, innovations are important. Tomorrow, the road will surely be made up of innovative materials, allowing it to self-repair and be self-sufficient in energy. The pavement will be heated or cooled, depending on the weather conditions. It will also give pride of place to organic materials, sourced to replace materials of petroleum origin. Sooner or later again, the road will be able to self-diagnose pavement deformation and send traffic information. To do this, it will contain interconnected deformation sensors, optical fibers, or nanomaterials. Incorporated at the level of the tread, the optical fiber can measure the deformations. The changes in the frequency of the light inside the fiber indeed testify to early deformations and make it possible to act to avoid more significant degradations. The self-diagnosis could also be done through nanocomposite exhibiting piezoelectric electric properties. The idea is then to deposit a layer of a nanocomposite based on clay, graphite, and carbon nanotubes in the wearing cause. Thus, as soon as the pressure is exercised on the road, the nanocomposite generates an electric current between two aluminum electrodes. Once the signals have been processed, this provides an image of the state of the road or traffic. Its perspective for more resilient infrastructure. That is to say, some of the benefits of the intelligent transport system for more resilient infrastructure. Today, ITS at a crossroads because the challenges are numerous and go well beyond the framework of technological innovations or the driver-vehicle infrastructure relationship. The ability to optimize mass data related to the movement of the population while minimizing the risk of accident and the carbon footprints requires improvement in the management of big data. The main constraint will surely be systematic. Indeed, in the years to come, intelligent transport system will have to manage a complex system combining traditional vehicle, connected vehicle, and autonomous vehicle. It must also be optimized under economic, that is system cost, security, that is reduction of accidentology, energy, reduction in consumption, environmental, reduction of its carbon footprints, and practical, that is the payment, accessibility, etc., down to constraints. It's and other modes of transport. That is, the intelligent transport system cover all modes of transport, including ground transport, such as private motor cars, utility vehicles, and public transport, as well as rail, sea, and air transport. The maritime and aviation sectors have long integrated into the intelligent transport system as practiced in their daily activities. Where here, ticketing, tracking, and tracking of planes and boats, automatic piloting, management of flights, safety and security equipment are all done using the system. The R5Gs. The answer to the question that requires planning, design, construction of infrastructure that are adaptable to climate change and respond with the correct level of service to the concerns of users in an environment of the ICT, that is information and communication technology, digitization and telecommunications, makes us think about fifth generation routes. The fifth generation routes, after the mule track, the Roman route, the macadam, then the motorway, the time has come for the fifth generation routes, or the R5Gs. In the more or less near future, this will integrate various technical developments and multiple the interactions between vehicles and infrastructure in order to better respond to the challenges of sustainable development, energy transition, and mobility. Indispensable to the economy and to the proper functioning of any modern society, the road must participate in the challenge of energy transition in terms of mobility and respond to the societal challenges of sustainable development. This objective is tenable. This objective provided, however, that the deployment of the fifth generation route can start now. At the crossroads of different engineering fields, road infrastructure crystallized many innovations in the fields of materials and structures, energy and information. The first 4 generations of routes, the mule track, the Roman route, the Charles de Marc Adam, the motorway, have each time greatly improved the service provided to their users. It's time to invent the next generation, which will be scalable, positive, energy, cooperative, and acceptable. Materials and structural engineers design long life pavement for high traffic routes. Thanks to very resistant materials, their wearing costs will make it possible to avoid the cost of maintenance operation, which includes the cost of delays caused to users, in particular in the event of traffic congestion. Although more expensive to build, these techniques, based on bitumen epoxy or gravel fiber hydraulic coating, will allow the rolling surfaces to be renewed only every 30 years. The roads will collect and store thermal and electrical energy using wind turbines placed in the vicinity, geothermal power stations buried under their surfaces, photovoltaic power stations installed around them or in their surface. This energy will be able to regulate the temperature of the pavement to auto-defrost it in winter and cool it in summer, supplying its own signaling, traffic, and telecommunications equipment. The surplus energy will be redistributed on the electrical networks or will supply electric vehicles at the charging points, or even directly by driving through contactless charging solutions. As a result, the road will be connected to smart electricity grids and will smooth production and consumption peaks by producing or storing energy wisely. What the R5G will look like. Sober roads, long life, silent, the construction of which consumes a minimum of non-renewable natural resources. Positive energy roads that promote the emergence of innovative technical solutions aimed at significantly reducing external energy inputs into the transport system and acts on the efficiency of the energy supply intended for vehicles and position the road as a source of energy. Like systems developed for a long time in the building industry, photovoltaic panels, solar water heaters, etc. Resilient roads whose repair makes it easy and quick to return to a level of use close to or even identical to that before a disaster. Self-diagnosing structures propose a paradigm shift in terms of maintenance, today largely governed by periodic inspection and progressive surveillance. In the event of pathology, self-diagnosis enables detailed inspections to be triggered on demand while helping to characterize the evolution of the structure or its loads in order to reduce costs during their life cycle. The R5G will also look at automated routes in order to guarantee the optimization of the traffic flow capacity in perfect synergy with communicating vehicles. Safe and efficient routes that inform the user on his movement, the weather conditions, the level of traffic, our location and the surrounding resources, which will provide enhanced safety and security conditions. The R5G connected and cooperative routes, the sharing of information between users, vehicles, infrastructure, and traffic centers in order to offer more efficient, more reliable, and safer mobility services. The infrastructure will benefit from this with greater availability and reduced maintenance costs. The deployment of these cooperative systems marks a further step towards the automation of driving. Conclusion. The opportunities offered by the intelligent transport system and possibly the R5G will only materialize if road authorities have a clear and thoughtful strategy for bringing together over time disparate existing systems and services as well as operational approaches. For example, imagine that each vehicle transmits a signal for every pothole or fault on the road, thus relaying detailed information on road conditions to transport agencies. In the short term, this information will be used to resolve immediate problems. In the longer term, it could help build better, more resilient roads. Intelligent transport system will be soon classified in the archives of the past because the R5G, this is today. Thank you for your attention. I welcome any question in areas where you find doubt in the course of my presentation.